apply congruence in triangles. So in this lesson we want to be able to identify congruent parts of congruent triangles and prove that two figures are congruent. And we want to use the properties of congruent figures to solve problems about congruent figures. So what is a congruent figure? A congruent figure, in two congruent figures, the corresponding parts of one figure are going to be congruent to the corresponding parts of another figure. That refers to all corresponding sides and all corresponding angles. So in short, they have the same size and the same shape. All of the corresponding sides are the same, all of the corresponding angles are the same. So your corresponding parts. Now when we have congruent figures, we want to write a congruency statement that demonstrates how our figures are congruent. So if we look at these two triangles, we want to write a congruency statement for them. So I'm going to choose an angle to start with, and I see that angle J is congruent to angle T, and that angle K is congruent to angle S. And notice that tick mark on the side tells me that JK is congruent to TS. It's important that I go from the same direction. So J is congruent to T, so that's why when I listed JK, I start with the angle T when I list the TS side. Alright, so let's look at the other congruent sides. I've got KL. If I keep going around the triangle, KL is congruent to SR. And notice those sides have the same tick marks and my angles are the same. And then lastly, the third side, I've got LJ, and LJ is congruent to RT. So that's a list of all my corresponding sides. Now we want to look at our angles. And we already discussed this a little bit, but I know, for example, that angle J is congruent to angle T. So that's one set of corresponding angles. And I know that angle K is congruent to angle S. So that's 2 out of 3. And then my third angle, angle L, is congruent to angle R. So I've got my 3 corresponding angles. So now I want to write a congruency statement. When you write your congruency statement, the angles must be in the same position in the statement to represent that they are corresponding and congruent. So notice in my little congruency statement here, angle J and angle T, which are congruent angles, are in the same position, in the congruency statement. They both come first. And if you look at the side lengths, JK is the first side length in this triangle, and TS is the first side length in the second triangle. And those side lengths were congruent. So just make sure that all the pieces line up so that the congruent parts match. Okay? Example 2. We want to find the value of X and we want to find the value of Y. So I've been given that these two shapes are congruent. So because I know that the congruent parts are lined up, I just need to figure out where the X is that I want to use. So notice X is this line QR, segment QR. Now QR lines up with FG. So if I want to solve for this X value here, if I want to solve this equation, then I want to set QR equal to FG. And then I can just solve from there. So I know that QR equals FG. So then I can set up my equation as 2x minus 4 equals 12. So then I know that x equals 8. Okay? So there's my x value. Now I want to find my value of y, and notice that when I'm looking for my y value, it's stuck in here as an angle measure, and it's angle Q, and angle Q is paired up with angle F. So I know I can write that angle Q is equal, or the measure of angle Q is equal to the measure of angle F. So I know that 6y plus x, which we just figured out was 8, is equal to 68. So then y must be 10. So that's how I use my congruent parts to find the values of x and y. All right, go ahead and try the practice and then check your answers. All right, so in the first problem, you were supposed to identify all the congruent parts, just like example 1, and write a congruency statement. So there are your sides. These are your sides, your angles, and then here is your congruency statement. Now, is it a triangle? And here we just have just a random polygon. So you got 4 sides, 4 angles, and then there's your congruency statement. In the second problem, you were supposed to find all the values listed based on the fact that these two figures are assumed to be congruent. So check your answers. Let me know if you've got questions. All right, in example 3, if our wall is divided along JK, will the sections of the walls be the same size and shape? So if we take a look, our answer is yes, but then it says explain. So if we take a look, angle A and angle C and angle D and angle B are all going to be congruent because right angles are congruent. I know that AD is perpendicular to AB because of the right angle. And I know that AD is also perpendicular to DC because of the right angle, because lines that are perpendicular to a transversal theorem. Okay, so I've got 4 angles congruent. Now, I know that AB and DC are parallel, so that means that this is my transversal, which makes angle 2 and angle 3, which I have since covered up, but that makes angle 2 and angle 3 alternate interior angles, as well as angle 3 and angle 4 and angle 1. And then I know that this line JK is congruent to itself because of the reflexive property. Now, all other corresponding sides are congruent because the diagram told us so. So since all of my parts are congruent, then those two shapes are going to be congruent. All right, so here is your practice. And you need to write a congruent statement and then come back and check. All right, so here are your congruent statements. The first one is like that. The second one is not congruent because we don't have enough information. This is the congruency statement for the third one. And the fourth one could be a couple of different answers. All right, so let's talk about the third angle theorem. In triangles, we've got 3 angles, and if 2 angles of one triangle are congruent to 2 angles of another triangle, so in this case A is congruent to D and B is congruent to E, then by default, or the third angles theorem, angle C must be congruent to F. So, if A is congruent to D and B is congruent to E, then C is congruent to F. That's our third angles theorem. So if I'm looking at example 4, I want to find the measure of angle BDC. And if we look, I'm hoping you can see my 2 triangles, but I've got 2 triangles that are overlapping, and this is 45 degrees, which means that this is 45 degrees, because those lines tell me they're congruent. And this is 30 degrees, which lets me know that this is also 30 degrees, because those angles are congruent. So if this is 45 and this is 30, then I can find the measure of BDC, because I know that 180 minus 45 minus 30 is going to give me this angle. So BDC, which is this angle right here, is going to be 105 degrees. All right. This is almost the exact same problem, just slightly different numbers. So hopefully you'll see that this angle and this angle are congruent to these 2 angles, which means that these 2 angles must be congruent. And again, what are we doing? YXW, which is this angle right here, is going to equal 105 degrees. All right, so just like with segments and angles, we have properties of congruent triangles. So the reflexive property of the congruent triangle tells us that for any triangle ABC, triangle ABC is congruent to triangle ABC. Reflexive, like looking in a mirror, it's congruent to itself. Our symmetric property tells us that if ABC is congruent to DEF, then we should be able to flip that around, and DEF is congruent to ABC. It just means that you can write it both ways, and it still says the same thing. And then transitive property of congruent triangles says that if ABC is congruent to DEF, and DEF is congruent to JKL, then ABC must also be congruent to JKL. All right, take a look at the practice problems and then come back and check your answers. All right, in the first one, y is 25, y is 70, y is 11, y is 19. And then on the slightly harder problems, x equals 3, y equals 1, x equals 5, y equals 2. All right, last bit is some proofs. So we want to prove the third angles theorem. So we've been given this diagram, which pretty much tells us that angle A is congruent to angle D and angle B is congruent to angle E. So that was given. Now, I know that if I add up all the angles of my triangle, they're going to be 180 degrees. Why is that? That's the triangle sum theorem. that the sum of the measures of the interior angles of a triangle equal 180 degrees. So I know then that the sum of these two triangles, if I add the interior angles of this first triangle, they're going to equal the same sum as this triangle. That's my transitive property. I know that this equals 180 and 180 equals this, therefore they must be equal to each other. Now, coming from step 1, these are congruent, and my definition of congruent angles tells me that the measure of angle A must be equal to, sorry, that's a typo, this should be an equal sign, not a congruent sign, equal. And the measure of angle B is equal to the measure of angle E. That's the definition of congruent angles. So, since those are equal, that means I can take my measure of angle D, which I've got right here, and I can insert it where angle A was. So anytime I saw an angle A, I can put angle D. And anytime I saw an angle B, I can put angle E, because they're congruent. So that was substitution. I substituted D for A and E for B. So now, notice I've got the same measurements, the same angles on each side. So they kind of cancel each other out. So that's my subtraction property of equality. And now I know that the measure of angle C is congruent to the measure of angle F. So, and again, that should have been an equal sign, sorry. The measure of angle C is equal to the measure of angle F. Therefore, angle C is congruent to angle F. And that's the definition of congruent angles. All right, so next proof. Given that E is the midpoint of AC and BD, so there's E, we want to prove that these two triangles are congruent. So first of all, I know that AB is congruent to DC from my picture, because those little tick marks are given in my diagram. Next, I know that BE and DE are congruent. BE and DE are congruent because E is their midpoint. And similarly, I know that AE and CE are congruent because that's the midpoint. So that's the definition of a midpoint. E was the midpoint, so those segments have been cut in half. All right, next. If you look here, AEB angle AEB is congruent to angle DEB. And why are they congruent? What kind of angles are they? They are vertical angles. So that's my vertical angles theorem, tells me that those two angles are congruent. Now we've been given this diagram, and I don't know if you noticed, but these two lines, AB and DC, are parallel, which means that I know that angle A must be congruent to angle C, because these are two parallel lines cut by a transversal. And the same thing is true of B and D. So that's alternate interior angles theorem. And now I know that all of my corresponding angles and all of my corresponding sides are congruent, so that's my definition of congruent figures. Those two triangles must be congruent. All right, last proof. Given that FH is congruent to JH, FG is congruent to JG, and angle FHG is congruent to JHG, and FGH is congruent to JGH, we want to prove our two triangles are congruent. So first of all, I'm going to go ahead and write my two sides that are congruent. That was given. I know that this side is congruent to this side, and I know that this side is congruent to this side. So I got 2 out of 3 sides congruent. Well, I also can prove that my third side is congruent because they share it and is congruent to itself. So that's the reflexive property. HG must be congruent to itself. All right, now we're going to look at the angles. Those were the angles that I was given. So I know that this angle and this angle are congruent, and we were given that this angle and this angle were congruent. So now we've just got to prove that HFG is congruent to HJG. Well, if I have two angles that are congruent to 2 angles of another triangle, then I know that their third angles are going to be congruent by the third angles theorem. So now that I have 3 sides congruent and 3 corresponding angles congruent, I know the 2 triangles are congruent by the definition of congruent triangles.